Okay, I'm continuing that packet with number 13. So this is an antiderivative problem, and the first thing you're going to do is expand this. Then you're going to distribute. And then you're going to take the antiderivative. And the answer was B. Sorry, I was supposed to say that at the beginning. Okay, number 14. The answer was D as in dog. This was the problem. Okay, so this looks like a regular limit problem, but you'll notice right away that you cannot substitute 0 in there in the denominator. And this is actually one of those limit problems using the definition of the derivative that looks like this. Okay, because it's the limit as h goes to 0, there's h in a denominator, and it's something minus something. So now you have to figure out what the something is. So if you compare f of x and e squared, that would hopefully give you a hint that your f of x is actually e to the x. It can't be e squared because the derivative of e squared would be 0 because e squared is a constant. But if you make it e to the x, then the derivative would be e to the x and you're good. And of course this is where x equals 2. So now that you know that f of x, the original was e to the x, then you just have to find the derivative of that, which is e to the x, but don't forget that x is really 2, so you're going to get e to the 2, and that was choice D. Okay, number 18, the answer was D as in dog. It seems really complicated, but you just have to do what you know, and the magic words here is the word approximation in the question. So this is one of those tangent line approximations where you're doing like the square root of like 24. So we're just going to do what we know how to do. So we're going to start off with the equation for the tangent line. And you were told in the story that f of 1 is 4. So that means when x equals 1, y equals 4. So I can substitute that. Okay, now the next thing you need is the slope, which is m. Well, you already told what the slope is. The slope is right here, 2x plus 1. So you just need to find it when x is equal to 1. So you'll get 2 plus 1 is 3, and now I can substitute that. Okay, so this is the equation of the tangent line, and normally when we're doing these approximations, you take some value now and you put it in for x. Well, the only thing that would make sense is to put in 1.2, because it's saying what is the approximation for f of 1.2. And also I had told you that you should be able to calculate that in your head, that you shouldn't have to need a calculator. So 1.2 minus 1 is definitely something that you could do in your head. So if we simplify, we get this. And then if you simplify further, you get this. And then you add 4 to both sides, and you get 4.6. And that was choice D. Okay, for number 19, the answer was A. You needed to find out about concavity, so that would be the second derivative. So that's the first derivative. That's the second derivative, and you set that equal to 0. Okay, so now I know x equals 2 is a possible inflection point, so I'm going to make a wiggle graph, and we're going to substitute into the second derivative. So if you do f double prime of 0, you're substituting into the second derivative. You get negative 12. Okay, and then if you try f double prime of 3, you'll get 6, it's positive. So that means that when x equals 2, that's a point of inflection. And the question is asking for when it's concave up. So it's concave up when it's positive, so that means when x is greater than 2, it will be concave up, and that is choice A. Okay, so now we skip to number 22, and we're looking for maxes and mins with this. So to find the max or min, you're going to take the first derivative and set it equal to 0. So they already gave you the first derivative, and we're just going to set that equal to 0. So it's beautiful and factored for you already. You'll have 3 solutions. I'm sorry, the answer for 22 is A. Okay, so we get x equals 2, x equals 3, x equals 4. So those are 3 solutions, and then we're going to make a wiggle graph with 2, 3, 4. And for maxes and mins, it's always in the first derivative. So the easiest way for you to do this, because this would be without a calculator and it's very time consuming to do all these calculations. So for example, let's say that you do f prime of 0. Okay, so remember, you're substituting into this thing right here. Okay, so if you put 0 into the first parentheses, you're going to get a negative value. So that's all we care about, that the first one is negative. The second parentheses will always be positive because it's something squared. So you don't have to figure anything out. It's always going to be positive. And the third one, if you put 0 in there, you're going to have a negative number to the third power. That's going to give you a negative. So you have a negative times a positive, which is a negative, and a negative times negative is positive. If you start plugging in all these different numbers, because for example, you need to try a number between 2 and 3. So if you do f prime of 2.5 and you try to do all those calculations, you'll be here all day. So for example, if you look at the first parentheses, you're going to have 2.5 minus 2. So that's just going to be a positive number. The second set of parentheses we always know is positive because it's squared. And for the third one, you're going to get 2.5 minus 4, so that would be a negative number cubed, which is negative. So positive times positive is positive, and then a positive times negative is negative. So that's what I did for each of these, and you should end up with a positive, negative, negative, positive. Okay, so I'm just going to erase here and make some room. So we're going to look and see what's happening at each x value. Okay, so at x equals 2, it was increasing and then decreasing. So there's a max at x equals 2. At x equals 3, there was no change in the sign, so there's no max or min there. And at x equals 4, it was decreasing and then increasing, so there's a min at x equals 4. So now you're going to look at the choices. You have choice 1, 2, and 3. Choice 1 says there's a max at x equals 2. Yes, that's true. Number 2 says there's a min at x equals 3. That is not true. For number 3, there's a max at x equals 4. No, that's not true. There's a min at x equals 4. So the only thing true is number 1, and that is choice A. Okay, now we're moving on to 24, which is a related rates problem. So the radius of a circle is increasing, so that's going to be dr over dt. At a certain instance, the rate of increase in the area of the circle, so the increase in the area is equal to twice the rate of the increase in its circumference. So 2 dc dt. What is the radius of the circle? So the goal here is to find r. Okay, so since we're talking about area here, we're going to start with an area formula, pi r squared. So if we find the derivative of each side, we will get this. Okay, Now here's the problem. You have dA over dt, we don't know anything about that. We have r, that's what we're looking for, and we have dr over dt, we don't know anything about that. But I do know that dA over dt is equal to 2 dc dt. So I'm going to put that in and see if that will help me. Okay, this can at least simplify a little bit because the 2's would cancel on each side, leaving me with just this. Okay, so now I need dc over dt, which I don't have. R is what I'm looking for, and I still don't have dr over dt, so it looks like this did not really help me too much. However, the one thing that I did not do anything with yet is the circumference. And I know that the circumference is 2 pi r. Okay, so if I find the derivative of that, I get this. Okay, so that's dc over dt. So what can I do with that? Well, I can take this and I can substitute it into this because those two dc dt's are equal. So I'm going to get this. Okay, so if you divide both sides by pi, those are gone. If you divide both sides by dr over dt, those are gone, and you're left with 2 equals r, which was choice D. Okay, number 25 is implicit differentiation. So first we're going to start with the product rule. The first times the derivative of the second plus the second times the derivative of the first. And don't forget the derivative of negative 3 is 0. Okay, so I'm going to keep all dy dx on the left. Okay, sorry, that was my phone that was ringing. So if anyone can figure out what that ringtone is, there is 2 extra credit points in there for you. Good luck on that one. Okay, so I just want to say that I moved this over to the right side, so that became negative, and then the negative 3 moved to the right side, so that became positive. Okay, I'm going to factor out dy over dx. And I get that. And then I divide. Okay, and that would be the answer, except that it's asking you to find it at the point negative 1, 2. So you're going to put negative 1 in for x, 2 for y, and when you're done you should get 7 over negative 11, which was choice A.